Hi, welcome to AP Physics 1 Unit 1 review. In this unit review, we will be covering kinematics, which is the mathematical description of motion. So this does not cover what forces cause this motion. We are only focusing on how the object moves. So let's get into it. So the first thing that you would need to know is the difference between a scalar quantity and a vector quantity. So a scalar quantity is a quantity with only magnitude. So this means that it has a single numerical value indicating the amounts or the units. So your answer would just be units. All right, so a vector is a quantity with both magnitude and direction. So how you would have your answer is you would have the positive units and the direction. Now let's define position, displacement, and distance. So what is position? Position indicates the location of an object. Now, is that a scalar or a vector quantity? Well, I'll give you a hint. Another description of position is that it is the linear distance and direction from a point of reference. So, if you said it is a vector quantity, you would be correct. So some symbols of position are R, S, or X. Notice how we have these little arrows over these symbols. That indicates that it is a vector quantity. Now, moving on to displacement. So displacement is the net change in position. Now, is that a vector or is that a scalar quantity? If you said vector, you would be correct. So some symbols for displacement are D, change in position, or change in R, change in position, or change in X. And notice how we are seeing the arrows again. All right, now let's move on to distance. Distance is the length of the path traveled. Is that a scalar or a vector quantity? If you said scalar, you'd be correct. All right, so I'm just going to go more into depth about each of the three vocabulary words. So let's say we have this ball right here. And it moves to this position right here. So let's just describe what we're seeing here. So this would be the object's initial position, and this would be the object's final position. Looking at this squiggly line, let's say we stretched it out all the way. So it's this one really long line. That would be distance, because that is the length the ball has traveled. All right? But displacement is the net change in position. So it is the shortest path the object traveled to get to the final position. Just think of it that way. So it would be just this line right there. That is displacement. All right, let's do an example problem using what we just learned about distance, position, and displacement. So let's say we have a ball that starts at the 5-meter line, and then it moves to the 10-meter line, and then it moves to the 4-meter line. Also, just pretend that the ball is directly on top of the number line. I didn't draw it that way because it would be kind of hard to tell what's going on. Okay, now with that out of the way, let's describe what's going on. So let's first find the initial position. So initially, the ball is 5 meters away from the 0-meter line. And because position is a vector quantity, you would also include direction. So because it is directly right from the 0-meter line, you would say that the direction is 0 degrees. Now let's find the final position. Final position is where the ball ended up. It ended up at the -4 meter line, and that is 4 meters away from the 0 meter mark. Now again, position is a vector quantity, so you would also need to include direction. So it would be 180 degrees because the ball is directly left of the 0 meter mark. Now let's find distance. So the ball technically traveled in two parts. It first traveled from the 5 meter line to the -10 meter line, and in total that would be 15 meters. And then in the second part, the ball traveled from the -10 meter line to the -4 meter line. So that would be another 6 meters. And then you add them together to get 21 meters. And because distance is a scalar quantity, 21 meters would just be an answer. You would not need to include direction. Now let's move on to displacement. Remember, in displacement, you only care about where the ball started and where the ball ended up. So in other words, you care about the change in position. And that is equal to the final position minus the initial position. So in this case, the ball ended up at the -4 meter line. So instead of saying +4, 180 degrees, you would just say -4 meters. All right, and then minus initial position, so minus +5 meters. And that would give you -9 meters. And then converting the -9 meters to vector form, you would say the magnitude, which is 9 meters, 180 degrees. Okay, hopefully that example made sense. All right, so now let's define speed and velocity. Speed indicates how rapidly an object moves along its path of travel. So would that be a scalar quantity or a vector quantity? Well, if you said a scalar quantity, you'd be correct, because it is the time rate in change in distance. So the symbol for speed is just v. And to calculate the average speed, you would do the change in distance over the change in time. Now, velocity is a quantity that indicates how rapidly an object moves and in what direction. So this would be a vector quantity because it has both magnitude and direction. And the symbol for velocity is a v with the vector symbol over it. And in order to calculate the average velocity, you would do the change in position over the change in time. And that is also equal to displacement over time. Alright, so now let's look at some graphs. So this graph that we have here is a distance versus time graph. So the x-axis is time in seconds and the y-axis is the distance traveled in meters. Okay, so let's just kind of dissect this graph together. So we know that slope equals change in y over change in x. Now on this graph, that is change in distance over change in time. And that is also equal to speed. Okay, now what is going on in this interval? Well, you can tell that it has a linear slope. In other words, the slope is constant. It's not changing. So you would say that the speed is constant because the speed is slope. Now what is happening in this interval? Well, it also has a linear slope. The slope is also constant, but the slope is also 0. So in this interval, you would say that the speed is 0. And this makes sense because you can see that the object is not traveling any more distance. And you can actually check this with the speed formula of change in distance over change in time, which would be 0. Now you should be able to describe what's going on in this interval. If you said it has constant speed, you are correct. And how you would explain that is that it has linear slope. Okay, let's actually write that out. Linear slope equals constant speed. Alright, so now let's look at this distance versus time graph. So what do we notice here? Well, for starters, we don't see any linear slope. So we can say that object does not have constant speed. But I also want to describe how the object is moving. But we know that slope equals speed. So if we find the slope of the tangent line, we can get the instantaneous speed. So let me draw a couple of tangent lines here. And let's also write down that the slope of the tangent line equals the instantaneous speed. And just a refresher, the instantaneous speed is just the speed of the object at that specific point. So what do we notice about the slope of the tangent lines? Well, we notice that they're actually getting less and less steep. So the speed is getting lesser and lesser. So we can say that for this graph, the object's speed is decreasing during this interval of time. Let's describe acceleration. Acceleration is a vector quantity indicating how much change per unit time in the direction of change. So it can also be said that acceleration is the time rate of change in velocity. Acceleration equals the change in velocity over change in time. So final velocity minus initial velocity over change in time. And that is the average acceleration. All right, so let's look at a graph. So what is the slope of this graph? Well, again, it's change in y over change in x, so it would be change in velocity over change in time. That equals acceleration. Let's kind of dissect this graph a little bit. Okay, so what's going on in this interval? Well, if I draw a tangent line over it, I see that it's actually covering the entire line over there, or that entire interval over there, and that the slope is 0. So what does that mean? Does it mean that the object is not moving? Well, no. Let's look at the y-axis again. The y-axis is velocity. So that just means that the velocity is constant over there. But that also means that a constant velocity means that it's not changing. So acceleration is 0. So let's write that. When the slope equals 0, acceleration equals 0. Because velocity does not change. We can say that in this interval and in this interval, acceleration equals 0. It's also important to note that in a velocity versus time graph, a linear slope means that the object has constant acceleration in that interval. So now you can read the velocity versus time graphs. Okay, now let's move on to equations. All right, so there are 3 equations in this unit that you really need to memorize. 2 of them are about velocity equations, and the third one's displacement. Okay, the first velocity equation is velocity final equals velocity initial plus acceleration times time. And notice how all 3 of these values are vectors, so they can be either positive or negative. So really pay attention to direction there. The second velocity equation is velocity final squared equals velocity initial squared plus 2 times acceleration times distance. One thing to note about the velocity equation is that this is magnitude. So it would always be positive. The displacement equation is displacement equals initial velocity times time plus 1/2 times acceleration times time squared. You also need to note that acceleration must be constant for all three of these equations to work. And like I said before, vector directions must be accounted for. So that's your positive/negative signs. We are finally on the last topic of Unit 1, which is free fall. So when an object is free falling, it is under the sole influence of gravity. And all objects free falling have the same acceleration rate. So what is that acceleration rate? Well, that is also known as g, and that is equal to 9.8 meters per second squared down, or 270 degrees. All right, please memorize that number because you will need it. So that wraps up the Unit 1 Physics 1 Kinematics review. As your tutors, we thank you for watching, and please like and subscribe if you found this video interesting or helpful. Thank you so much, and see you in the next video. Bye!